Welcome back, everybody. This is the Additive Snack podcast, and I'm your host, Fabian Alefeld. Today, we have a very special guest with us, someone who's been instrumental in integrating additive manufacturing into one of the most beloved brands. We're thrilled to welcome Ronen Hadar, the Senior Director of Additive Design and Manufacturing at LEGO. Ronen, it's an absolute pleasure to have you with us.
Thank you very much, Fabian. Remember, everybody, it's the LEGO Group. It's great to be
LEGO
here.
Group.
Yes.
Perfect. So let's kick things off by diving into your personal journey with additive manufacturing. Can you share a bit about how you first got involved in additive manufacturing? What drew you to AM, and how did it also become part of your work at the LEGO Group?
Yeah, definitely. In 2010, I started a PhD in collaboration with the University of Southern Denmark, here in Denmark, and the LEGO Group, in fact. And the purpose of that PhD was to explore new manufacturing technologies, specifically from a supply chain business model point of view. So what is going to enable the supply chains of the future? And that was also the angle that I came into additive manufacturing. We were looking specifically into digital technologies, what kind of digital technologies were out there that could really disrupt sort of supply chains and how we move goods from one place to the next and how we set up our manufacturing footprint. And because of that, additive manufacturing was quite interesting. Of course, at the time, I would argue even today, still very much driven by prototyping. So it wasn't really there for mass production. But anyways, very interesting to start exploring. And that's how I got interested with AM and the possibility of what AM can actually do to a company like the LEGO Group. Yeah.
Very interesting, because especially back then, as you said, additive manufacturing was mainly a prototyping technology. And today, a lot of people talk about supply chain challenges that we're still experiencing since COVID, and additive manufacturing is truly becoming one of those tools that alleviate these challenges and these bottlenecks that we do see in supply chains. But back then, you were really one of those early, I would even say pioneers in that case, right? Who really identified that opportunity that additive manufacturing brought with it.
I think a lot of companies see the light in that sense. I just don't think that we as an industry have really got to that point where we can really talk about digital supply chains. And there are maybe a few that actually do that in different applications, really.
Yeah, exactly. But we're starting to see these applications, as you said. It starts with tooling, where supply chain challenges are still seen today quite significantly, but also some smaller end-use parts. But in any case, LEGO has been using additive manufacturing for quite some time now, as you mentioned, also mainly in prototyping. Can you tell us a bit more about those initial steps that the LEGO Group has taken in adopting additive manufacturing as a technology?
Yeah, definitely. We have a whole division in the LEGO Group that's called Rapid Prototyping, and that's an agency that is a part of our product development. They have been using additive manufacturing since I believe the late 80s or beginning of the 90s. So a very long time. I also believe we were one of the first adopters of 3D printing as a prototyping tool back in that time. So we definitely have a long history with that part. Also, we have been using metal additive manufacturing in our molding supply chain and still do for almost 13 years now, which is another division here at the LEGO Group that is also working on metal AM towards molding applications. So that has been there for a very long time. This journey, which we are on right now, where we are looking at sort of two types of applications, the tooling, the jigs, fixtures, grippers type of part, and the actual question of can we use it for final parts, as in our case, Lego bricks. That journey we really started in 2012 as an exploration, and very seriously, I would say, in 2016. to actually say, okay, there's an opportunity here, but the technologies are not quite there. What do we need to build? What do we need to mature? What capabilities do we need to have in order to make that a reality for us?
Yeah, that's a big step, moving out of prototyping and into leveraging additive manufacturing for end use parts. Now, you mentioned you're taking different approaches to additive manufacturing, and if I'm correct, one of them is equipment. So, using
Yeah.
additive manufacturing to produce equipment. How did you get to that spot where you realized that additive manufacturing could add value in that space?
To be honest, it makes business sense.
Mm-hmm.
In that application, I think we could be we are cheaper than the alternatives most of the time. We are faster most of the time. And we have that digital part, that digital supply chain element to it that we can actually decentralize the production and produce on site on demand. So we back in 2012 when we started thinking about what can we do with this, that was a natural application. And also to be very honest, we weren't the first ones to think about it. I believe at that time Volkswagen, for example, was already doing all kinds of jigs and all kinds of grippers for their car production and other companies as well. So we definitely didn't invent that, but it made such good business sense for us in that application that we could find a couple of good cases and relatively quickly say, okay, we're not going to use traditional methods anymore for that. We are going to use additive manufacturing. And there are a couple of platforms in our equipment production that we are now completely saying, okay, this is with AM and we're not going back into traditional manufacturing. Of course, it's always good to have a fallback. And
Sure.
sometimes we also try with AM and we find out that it's not the right way. That's also very important that you are able to say that was not right to do it with AM. But most of the time we see that it's quite useful. A couple more things maybe is one that we see a lot of plastic to metal to plastic replacement. So we see a lot
Mm,
of things that we traditionally used to do with subtractive manufacturing in metal that we can actually move that into polymer printing. And the reason it
interesting.
was made with metal is because CNC and drilling and milling and all of that was the prominent technology to produce it before. It wasn't because necessarily metal needed to be the base material. And of course,
Mm-hmm.
that drove a lot of change management. There were a lot of stakeholders in the company that needed convincing. We needed convincing as well, right? We needed to see that it actually works, that it gives us the lifetime that we need, the quality that we need, the performance that we were after, the cost that we were
Mm.
after. And in many of the applications that we have tested, we actually got to that point where we said, okay, this works. This is good.
That is super interesting. Can you talk about a few example applications where you've made that transition from metal to polymer?
Yeah, definitely. I would say that jigs and fixtures is a very good application. I
Mm-hmm.
wouldn't say that we do all of our jigs and fixtures with AM or polymer AM within that, but we're definitely moving to more and more of that application. Uh, It makes sense because it's part specific. So every time we develop a new Lego part that needs to be somehow handled and fixated in that sense, we need to make a tool for that. So there is a need
Mm-hmm.
for speed, lead time. There's a need for cost, of course, productivity. And now that we have also implemented a global network of printers that is doing that on site, on demand, there's also the added value of doing that quicker and better without having to ship all those tools around the world. So that gives us additional benefits, not to mention the sustainability benefits of reducing CO2 emissions per those tools.
Glad you
Yeah,
mentioned that.
yeah.
So you truly have that vision that you had written about in your PhD about a digital supply chain now implemented for at least equipment applications. Is that right?
That is correct. Yes, we have what I would call a mini AM factory inside our big factory that is making Lego bricks. We have that in all our sites around the globe, in Mexico, in China, in the Czech Republic, in Denmark. and good colleagues working all around the world with these printers, making equipment on site on demand. And it's a fantastic opportunity to test the idea of a digital supply chain, because it's not a just go do type of a
Yeah.
thing, right? There's a lot of learnings that you need to take in that journey on how you set it up, how do you ensure quality, how do you calibrate and use data when you have a global footprint. There's a cultural aspects to working with colleagues all over the world in such a way that you design but
Hmm.
manufacture somewhere else. There's a lot of things to learn, and it's a fantastic opportunity to try it out on that program so we can evaluate if that's the way to go also on the other program, which is also the what we call the consumer goods program.
Yeah, must feel great to look back to 2010 and think about the fact that, really try to instill that into the Lego group, and now it's a reality.
Hmm.
So let's talk about the consumer goods that you just mentioned. What role does additive manufacturing play here for the Lego group?
Yeah, we are looking at it from two ways. The first one is more from a product perspective. We want to give uh, additional play opportunities for our consumers. For me, it's very important to say right here, right now, that additive manufacturing is not a replacement of injection molding. I'll say that in every opportunity that I'll get, because I really hate that people from the industry say it will replace injection molding. I can think of very few applications where that would be the case. Maybe it's just the industry I sit in. That could also be. Granted, I sit with the glasses that I have,
Yeah.
but I would say it's wrong to even say it that way, that it should replace something. Instead, I think it's much better to look into what it can give you that you can't do today. And for us, it's exactly what we are doing in terms of consumer goods. What can we not do today where injection molding is not the perfect tool to use, and therefore AM is a better tool to use. And that's from a product perspective, but
Hmm.
also from a supply chain operational perspective.
Yeah, and I think it's important to underline that additive manufacturing will not replace really any or conventional manufacturing technology. They're there for a reason, and they have a legacy that allows them to produce parts en masse with low cost and high productivity numbers. As I said, it's an additional tool in the tool belt that opens up additional applications, additional opportunities, and can circumvent certain challenges that we see with conventional supply chains that we've built over the past
Yeah,
50 years, really, in a globalized economy.
yeah.
You also don't just use standard additive manufacturing technologies, right? You're continuously scouting for new technologies. You even get involved with organizations such as ourselves as to push new technologies into the industry. Can you talk a bit more about your involvement there?
Yeah, I think the situation is, as everybody knows, that from my perspective, AM technologies are not quite where they need to be for real consumer goods production. Consumers have a certain expectation for cost, for first and foremost quality, look and feel, and all of those things. And we have already seen back in 2000, I think 15, that okay, everything that is off the shelf right now and everything we knew about was not going to do the job from a quantity and quality perspective, because we're
Hmm.
looking for super high quality parts for a super low cost and a very high quantity. And these are exactly the three things that AM is not very good at
Yeah.
in that sense, or a combination of those three things together. You can have one, but then not the other two. And that was very clear to us already back in those times. And that basically forced us to be a little bit more proactive on how we approach our development. And that's where we got in contact with some chosen suppliers and chosen partners and said, okay, what do you have in your drawer, or what do you have in the basement that you think could do it if we are ambitious and if we can really push the envelope? And a few suppliers ran away. I'll say that also. A few suppliers have just said, what you're asking for is impossible.
Mm.
Some of the largest companies in the industry. But a few suppliers also stuck around and took the challenge, even though they realized already from the beginning it's very difficult to achieve and still is very difficult to achieve. As I said, we're not there.
Yeah.
Yeah. So I think it's not a secret anymore, really, that we have been a part of developing with the OS the FDR technology, or at least tested and gave feedback on the FDR technology that EOS was developing and was very active in developing that. And if anybody is following the news, they would know of other investments that we have also made in the AM industry and into new technologies that we believe can really do something different than what we get right now in off the shelf in terms of quality, quantity, and cost. I will
Hmm.
say for the, I think now fourth time, we're not there yet. There still needs to be some development, but there has been some very positive, good developments in recent years where we are then positive that this could be done, and it is being done.
Yeah, and you mentioned people watching the news, and Lego is definitely on the map now when it comes to additive manufacturing and when it comes to a user that is pushing the limits and the envelope of additive manufacturing. And you mentioned the FDR technology, which stands for fine detail resolution. I think it's interesting to point out that roughly 6 months ago, all over social media, people would see a duck
Yeah.
rolling around on various people's desks. Can you
Yes.
talk a bit more about that application, how you developed it, and maybe even show it to the audience?
Have one right here. It's just happened to
Oh,
have one,
awesome.
so I hope everybody so can see it and maybe have seen also the videos that the video that we posted and also maybe some news about the duck. First and foremost, it's important to say that in this application of the consumer good, we are learning. Right, so we are not in a mass production mode yet. We're testing our own capabilities, we're testing technologies and technology readiness. We are testing and still developing sort of the whole value chain
Hmm.
end to end. And the printer is only a small part of that value chain. There's a lot of things before, all the way from the design into what we call the build development, which is where you prepare your print into your printing, but then also post processing and afterwards as well. I think a lot of people talk about post processing being the dirty little secret. I think there's dirtier secrets happening after post processing with everything that has to do with waste management and so on. But definitely there's a lot of stuff that still needs to be developed. And of course, we are very interested in seeing what our consumers think about this being a play experience by itself, but also about the quality and the playability and the whole experience around this duck. So it also helps us direct both our design journey, as in what kind of applications are we going to focus on, but also
Hmm.
help us focus our technology development in the right direction based on the feedback that we are getting. And to me, that is very, very important. And so many people in the Lego group helped us make this duck a success. It's not only my team here in ADNM that has been working on it. People through the entire value chain, from product development to engineering to supply chain, have really helped us make it a success. And not
Hmm.
only this duck, we've had the other pilots that we have also launched in order to continue to learn and get feedback from the market. And we will continue to do that in the next couple of years.
Super interesting project and awesome project. Right? Seeing that duck open its beak for the audience out there. There's wheels, the wheels turn, and that activates a mechanism where the duck's beak
Yeah,
opens up and closes. And you mentioned very early in the beginning that implementing additive manufacturing is really also all about change management. Is
right.
there a reason why you chose that application over others within your portfolio?
You're asking specifically about the duck?
Yes.
We were looking for applications that would highlight the advantages of AM. So the most obvious sort of category would be functional parts, because from the
Mm-hmm.
get-go you see there is a something different about this part. It's not what we usually do or what you would usually see out there. So for us, it was important that there's some sort of an integrated function. And then, of course, the duck itself is a throwback to a Lego legacy and a fantastic story around it, both for our adults fans that know this story, but also for the children that might not know that this used to be a wooden duck from the time that we used to be a carpentry. There's a little throwback for a little nudge for everybody in this particular application. But in general, we're looking for these kind of applications where we can really show the new play and the new play experience around it.
That's an awesome story, and I'm sure it helps you also to put this technology on the map internally within within your organization to make sure you have more and more support, because that thing is just really awesome. Now, we talked
Thank you.
about what's really interesting about this application and the benefits of the technology. Now, you said you're not there yet, and I think that's quite clear to folks who are out there. What are some challenges that you foresee scaling additive manufacturing as part of a true end-use manufacturing technology for you?
Yeah, that topic I can talk about for hours because to anybody who would listen from the industry, because I think there's a real call for action here on what needs to be done to really unlock at least the consumer goods opportunity within the
Mm-hmm.
AM market. I think there's a lot of other industries that are already satisfied with what they're getting. So maybe this is not what they're seeing. But for consumer goods, I can clearly and easily speak on behalf of all consumer goods manufacturers that are interested in AM and give a rundown of the challenges. And we are talking to each other. There's many of us that sort of get in contact between the different consumer goods segment, and we talk about the same challenges. So I think it's, at least for
Mm-hmm.
us, universal. But I would say that first and foremost, it's quality, right? So when we talk about consumer goods, consumers come with a certain expectation, and that expectation is set by the benchmark, which is most of the time in consumer goods, injection molding or a similar sort of forming type of technology. So when you get that sort of quality expectation, then that needs to be there. So when we are talking on about quality, first and foremost, safety. When does it break? How does it break? What is your material properties? We have a problem in the industry right now that across the board, across all technologies, our material choices are extremely limited. And if you go to a particular technology, say SLS, your material choices are even more limited, and they are controlled by a very small group of companies. And so also breaking that supply chain is very difficult. Whereas in other technologies like injection molding, you have hundreds and hundreds of opportunities. It's just a testament for the lack of maturity out there, both by users but also by OEMs themselves. Yeah, quality is definitely an issue. And of course, the most obvious thing is the surface roughness of AM parts. Here, I always get yeah, but you can use SLA, DLP type of parts. Yes, you can. Definitely, you can. They have other types of challenges from the powder-based technologies. So if you combine all of those topics together, then you
Mm-hmm.
still end up with sometimes with layer effects, or if it's powder, it's the grainy kind of look, and so on. But that's the typical sort of go-to quality. Then the second thing, and that's also across all of technologies, is cost.
Mm-hmm.
It's worse in some technologies than others, but across the board, it is simply too expensive. And the reason it's too expensive, in my book, and according to the analysis that we are also seeing right now, is that the productivity, there's a few reasons, but the first one is that the productivity of the machines is low. Even on some of the newer platforms that really promise to do mass manufacturing, that is not, from my chair, that is not mass manufacturing, and the unit cost is not nowhere near where it needs to be to really bring it into the hundreds of thousands and millions of parts that you really truly need to service your market, even if it is a small application within your company. Take the Lego Group, we don't make many products. There are in the hundreds of thousands of SKUs. So even if you are in the low volumes, you still need to do 500,000 or 1 million type batch production. So definitely You need to be there also from a volume. A second thing about the cost is also the material cost. And again, it's a chicken and an egg. The maturity and adaptation of AM is relatively small compared to other technologies. But that's a part of the reason for that is that materials are very expensive. And materials are very expensive because the volumes are very low. So you get this back and forth conversation of what needs to come first. And both need to happen,
Mhm.
but somebody needs to break the cycle. And then the fourth thing, so after cost, of course, comes the volume. But then the fourth thing is scalability. I hear a lot of AM companies talking about we're ready for mass production, mass manufacturing. The future is now type of a conversation. And I don't think, I don't mean to sound not to belittle anybody, but I don't really think they understand what it is to be in mass production and what it requires. And it's not just about putting a printer on the shop floor. You
Yeah.
need to really mature an entire stream of processes. You need to come and commission a machine and be able to service it in such a high level that you can guarantee a very high uptime and very low maintenance time. And all of those things, all of the AM machines that we have experience with are extremely labor intensive. And these things are very not scalable. And so I think there is also a level of maturity with the AM companies, even those that have been in the industry for several decades, of understanding what does it take to really service a high sort of throughput company like the Logo Group, like others. It is not put in a printer and see you later type of a thing.
Yeah.
Generally, I think that many of the technologies that we're seeing have very low TRL level, especially on post-processing. That has really not been an area in polymer in particular. It's bad. There's a couple of companies now coming up with more mature solutions. I would still say still very labor intensive, very low TRL, needs to be further mature.
Yeah. It's interesting to see how additive manufacturing is a highly viable technology for the aviation industry, for the space industry. We see a lot of medical devices being printed today that go into human bodies. But yeah, those are all applications that are high complexity, lower volumes, even customization in certain aspects. And consumer goods is a completely different animal for the additive manufacturing industry, as you said, for all those reasons that you mentioned. And we're just starting to tap into that industry, and it
Yeah.
helps us and everybody really to have people like you, Ronen, who really help us to understand even further how can we improve this technology for applications such as the ones that the Lego Group is looking at. And one challenge that you actually didn't mention yet, but is surely on your mind, is talent. Additive
Right.
manufacturing is, as you said, a still quite young industry, 30 years around. A lot of folks who are in the workforce were there before additive manufacturing was even a prototyping technology. How do you guys approach that? What roles are you looking for?
Mhm.
And are you even hiring so that some listeners could apply?
Yeah, definitely. And thank you for asking. I think that's also one of the biggest issues in the industry, the workforce, talent, and the general skills and competences that are needed. If we really want to scale up this industry, we need the people that can actually do that.
Yeah.
And there are not many out there. This is still a very small industry. So we're all fighting for the same pool of people. And then as the industry grows and grows, at least I don't feel like the talent pool is growing fast enough to really give us the options that we need. More needs to be done in order to prepare young engineers or other type of educations as well into the industry. I would say engineering is definitely where it hurts the most, where
Yeah.
we are definitely needing to do something. So the way we have approached it is to be proactive with universities and research centers about incorporating additive manufacturing into their engineering programs, doing projects, PhDs, bachelor, masters on all levels. We need to get more people involved already from early stage in their career so we can recruit them when they come so we don't have to fight for the same people who are already in the industry. Yeah, that's one thing. And then I would definitely say that I think within women, there's definitely even a bigger problem. I think it's a problem in engineering in general, but maybe
Yeah.
mechanical engineering in particular. But there should be also a focus on that. And there, I'm very happy with the Women in 3D Printing organization, for example, that it's doing a really good job. Although I really think that we can all help them do better in promoting that agenda. And then in terms of which roles are needed, so we are definitely recruiting across the board, and we're seeing roles such as a process engineer. That is the person that is working with the machine itself and a lot with the interaction of the material and the machine. There's obviously a lot of skills and competences that are needed in order to
Hmm.
stabilize a process and prepare that for production when you need sub 100 micron tolerances or even below, which we are definitely after. Then we have what we call build developers. Build developers is a competence that is to a company like us became a core competence where these people work with taking the generic design that is coming from product development or from our engineers and making that sort of ready for production, but on a mass scale. And because we are doing series production, we don't just nest.
Sure.
We really look into the tiniest of details into how we position the part, optimizing for quality, optimizing for cost, for volume, and so on. And then the third competence that we are looking for more and more actually is also data scientists, people with the particular understanding of additive manufacturing and how that applies into how to work with the data that you can extract from the various steps in your process, from your machines, from your design, from your simulations, from your environment, and so on. How do you bring that all into play, start understanding that data, and accelerate your development process? We really see a need for more individuals with that knowledge. Yeah, so definitely I would really encourage all my colleagues in the industry to help support all the organizations, universities, other NGOs that are working to increase the general pool of candidates in the industry. This would benefit all of us if we are active in that in the long term.
Yeah, couldn't agree more. That is a story that I hear a lot from various folks that I interact with. And yeah, I'm hopeful. I am hopeful because we do see a trend in making manufacturing cool again. Newspaper articles where all of a sudden people are possibly not only trending into the tech industry, but also back into manufacturing. Also, for the reason that digital technologies apply to additive manufacturing, and it is a
Right.
digital technology, and bringing these two together and merging them through, for example, data science is super interesting and is only going to elevate the industry as a whole. So really good points, Ronen, and for everybody out there, yeah, check it out. And yeah, you could work for the Lego Group and additive manufacturing, combine these two. That sounds like a really fun experience. Ronen, I want to thank you for being on Additive Snack. It was a pleasure having you on the show,
Thank you so
and
much.
I can't wait to see what comes next out of your organization.
Thank you so much, Fabian, and thank you, everybody.